Good afternoon, everyone, and welcome back to the class at Laurel Ridge Community College. I'm Professor Amit Prambhat, and today we are going to be diving headfirst into Chapter 2 of Python for Everybody, Variables, Expressions, and Statements. Up to this point, you have seen how computers run sequential instructions. Today, we are going to learn how to store, manipulate, and query dynamic data. We'll master memory allocations, mathematical operations, basic computer system structures, and how to cast data between different forms to write functional computer programs. Think of today's lecture as learning the fundamental vocabulary of Python. By the end of this hour, you'll not only understand what variables are, but you'll also write an interactive script that takes user input and performs calculations. So let's get started. Core syntax of Python language. Let's look at what the absolute foundational building blocks of our scripts mean. Constants and reserved words. In Python, constants are exactly what they sound like. Fixed values that do not change during program execution. If you write the number 123 or 98.6 or print the string hello, Python handles this as raw, immutable objects in memory. Now look at the right side of our slide. Python has a system checklist of reserved words. Words like class, if, while, and for. These are locked. They are exclusive commands reserved for Python's own controlled grammar. You cannot name your variables after them because the compiler expects them to represent specific logical operations. As we move forward into writing more complex logic, something we will explore deeply when we interface with control blocks in the next chapter, knowing how to keep your custom variables distinct from these reserved words is going to be your first major coding safety shield. Variable naming rules. Now you get to choose your own variable names, but you must follow Python's strict namespace boundaries. Rule number 1. Your variable names must start with a letter or an underscore. No numbers are allowed as the first character. Rule number 2. Only alphanumeric characters and underscores are legal. If you try to use a hashtag or a dollar sign or a dot, Python will throw a syntax error. Lastly, Python is strictly case sensitive. This is common pitfall to the Python compiler. Spam with a lowercase and spam with an uppercase s and spam all in caps are three completely different distinct memory slots. Make sure you keep your naming conventions consistent. I highly recommend using snake case for your variables to keep your code highly readable and standard compliant. This bridges us to core concept of mnemonic variable names. The word mnemonic simply means a memory aid. While in Python, doesn't care if you name your variables x1, q3, z9, OCD, or hours. Human beings absolutely do. Look at the code block in the terminal on this slide. If you read hours 36 or 35.0, rate 12.50, and pay equals hours multiplied by rate, you instantly understand developer's intent. The code documents itself. Beginners often get confused here because mnemonic names sound so much like official Python commands that they assume ours is a keyword. It's not. It's simply a highly descriptive label we choose to represent a physical memory location. Always strive to write clean, self-documenting code. It will save you and your peers hours of troubleshooting down the road. Assignment statements. Let's look at closely at assignment statements. In algebra, the equal sign asserts equality. In programming, however, the single sign is an active operator that means evaluate the expression on the right-hand side and assign the resulting value to the variable on the left. If you write x equals 3.9 multiplied by x in brackets 1 minus x, Python first looks up the current value of x in memory, performs the math, and then overwrites the same memory slot with the brand new result. This is a dynamic in-memory transaction. It updates state on the fly. Memorize this sequence. Right-hand side evaluated first, left-hand side variables assigned second. Master this, and you will avoid one of the biggest points of confusion for beginner programmers. Processing math input. Now that we have covered how to name variables and assign values to them, we need to talk about how we actually process data. Computers are, at their heart, calculators. In this next section, we are going to learn how to communicate mathematical formulas to our CPU, establish proper execution procedure, handle float and integer division constraints, and safely navigate data type boundaries. Let's take a look at Python's mathematical syntax. Take a look at this table of Python math operators. While addition, subtraction, and multiplications are straightforward, notice how we handle exponents and divisions. Exponentiation uses a double asterisk, writing 4 asterisk asterisk 3 evaluates to 64. For division, Python gives us two options. A single slash always performs a standard floating point division, meaning 9 by 2 gives you 4.5. But if you want a floor division, which truncates the decimal and rounds down to the nearest whole integer, you use the double slash. Finally, look at the percent sign. This is the modulo operator, which returns only the remainder of division. 23% 5 is 3, because 5 goes into 24 times with remainder of 3. Modulo is extremely useful for checking if numbers are even or odd, or managing cyclical tasks. Operator precedence. When you chain operators together, Python evaluates them using strict operator precedence. We follow standard algebraic rules, which you might remember as PEMDAS. First, Python always respects groupings inside parentheses. Second, exponentiation is evaluated. Third, multiplication, division, modulo, and floor division are processed. Finally, addition and subtractions occur. If operators have the same level of priority, Python evaluates them strictly from left to right. Look at the formula on the slide. To keep your code safe and readable, do not write massive, unreadable chains of math. Use parentheses explicitly to make your mathematical intent obvious to anyone reading your script. In Python, Every value has designated type, such as integers, floats, or strings. Python is a dynamically typed language, but it also is a strongly typed, meaning it will not let you perform illegal operations between incompatible types. For example, look at our terminal traceback. If you add the integer 1 to the string hello, Python will raise a type error. Why? Because the plus operator means addition to numbers, but concatenation to strings, it does not know how to resolve adding a number to words. To fix this, we use explicit typecasting functions like integer and float to safely convert our variables before running calculations. This type of boundary management is crucial when working with external data. Interactive user input. How do we get data into our programs? We use the built-in input function. When Python hits an input statement, it pauses execution and waits for the user to type something on their keyboard. But here is the catch. Input always returns user keystrokes as a string, even if they type a number. Look at the elevator control panel example in the slide. I think it's missing for now, but I'll be adding that. If we ask euro floor, then we user type 0, we cannot perform addition directly on the string. We must cast that input into integer flow before we can add 1 to calculate US floor equivalent. Mastering this input cast calculate pipeline is how we start building highly functional and interactive software. Exercise of gross pay. Now let's put everything we have learned today together into a practical exercise. Your goal is to write a script that prompts a user for their hours worked and their hourly rate, calculates their overall gross pay, and outputs the results to the console. Look at the sample solution. We capture hours and rate as strings, cast them both to the floats and to handle decimal coordinates, safely multiply them together and print out the result. Take a moment to run this script on your own terminals. Make sure it works and pay attention to how casting variables correctly protects your mathematical outputs from type errors. This wraps up our lecture on Chapter 2. We have covered variable rules, mathematical operators, precedence, data types, and user inputs. Do we have any questions about Python handles memory assignments or how to cast variables? Please go ahead and email me or send me a message. Remember, these materials are open source and released under a Creative Commons attribution license. And you can visit the Canvas course material and learn more about what we just discussed. And that's about it for this chapter. See you in the next class. Bye.